Hello everyone, and welcome to this section on failure mode and effects analysis. This is a contribution from our face-to-face course. This session is run by my colleague Elmar Fedro, and here we have a picture of our students here at TUM. They have to build these little propeller cars, and they have to perform an FMEA beforehand, and then they build the cars, and then we run a race and see how well our FMEA was performed. For this lecture, however, we would like to understand the purpose of performing a failure mode and effects analysis. We want to understand the ranking that we use, severity, occurrence, and detection, and calculate the so-called RPN, or risk priority number. And we want you to be able to perform an FMEA for a simple process. Failure mode and effects analysis, or FMEA, is a technique that is used to investigate all possible weaknesses in a product design and prioritize the weaknesses in terms of their potential to cause product failures. This prioritization enables then taking corrective actions on the most critical weaknesses in order to reduce the overall likelihood of failures of the product, especially in the customer's hands. We want to, it's a way of minimizing your risk. When this technique is used at the stage of evaluating the design of a product, it's called the design FMEA or DFMEA. And you can use the same technique in the design of a process that produce products or services. And then this method then will help to identify and prioritize the modes of failures in the process that might cause poor quality in the products. And this then is a process FMEA or PFMEA. The FMEA method in the design process facilitates concurrent design of products. It helps in receiving, recording views of a team on issues relating to product design or process design. It contributes to a better quality product and keeps the customer in focus, removing weaknesses in product and process design, but always thinking about what the customer wants. And this then will reduce the chance of future redesigns and helps us to provide a documentation of any design or improvement activities. Process FMEA is then performed to assess the effect of possible process failure modes on the quality of a product. And it really should be or must be performed for any new process or for any process that you currently have that you want to use to produce a new product. Of course, it's also useful when you have a defective, you have an outcome that you don't want, and you need to go back and investigate the root causes for that defective in an existing process. So FMEAs are typically performed by multifunctional teams to evaluate all possible failure modes and their effects for a product. So to actually do an FMEA, you need paper. All possible modes of failure are written down. Their possible effects on the customer are then predicted. So possible modes of failure, their possible effects on the customer are predicted, and their causes are analyzed. And then you rank the modes in the categories severity, S, occurrence, O, and detectability, D. So severity is how bad would the result be if this failure occurred. Occurrence is, how often do you expect this failure to occur? And detectability is what is the chance that this failure will be detective. And each of these we'll see in a minute are rated between 1 and 10. 1 to 10. So then from these we do some advanced math and we multiply them together to get the risk priority number. This is quality management language. We talk about RPNs, which is severity times occurrence times detection. The larger the RPN, the higher the risk of failure of the product through that mode. So that mode then would receive the priority to be addressed and corrected or prevented. And organizations often set threshold limits. Like if the RPN exceeds some certain threshold, then action must be taken. Just one more note on this. So the higher The larger the RPN, the higher the risk of failure. This means a high value for S means high severity. A high value for occurrence means that it would occur very often. A high value for detectability means high value means difficult to detect. So if all of these are high, then you have a problem, or you have potentially a problem that you would want to minimize that risk. So how does this work? Well, you've got something in your process that is causing or could cause an unwanted result. So we've got this cause, and it has an occurrence which we will rate as O, and a detectability which we will rate as D. So this cause then produces a failure mode. So if one failure mode can have several different causes, which then produces an effect on your product or service with a severity equal to S. Let's look at our little cars that we've got here. Well, we've got, hopefully you can see this, a little car with a propeller here going round and round, and it will accelerate due to that propeller in one direction. It's the propulsion, and there's some friction going in this direction. So our students have to put together this little car, and they have to follow the instructions, follow the process. They've got two parts to this. They've got an electrical side of things and a mechanical side of things. Very, very tricky here. You've got a little tiny motor, which is actually here. There's the motor. And you've got to put some batteries. You've got to attach the holder to the car and place some batteries in. And then you have to also attach the switch. And you have to put everything together. You've got, so you can't really see it here, but you've got the axle that's connecting the wheels. Got to make sure that the wheels are connected well to the axle. Got to make sure that they can turn. You've got to put the base of the car together. Got to build this little tower thing so that it doesn't fall over. You've got to attach the propeller. If we look at all of this, you've got an assembly process description. First, they have to do some cutting. They have to make sure they cut a hole for the switch, for example. Then they have to do bonding. So bonding today is very interesting, especially when you're talking about electric vehicles that need to be very light. In our case, we're using glue. So, but that ends up being quite a risk area in this in particular exercise. And so the motor has to get glued on there. The wheels have to get glued to their axles. The battery has to get glued on. We do have some taping. We added some tape for emergency. We have to do some wiring. We have to connect the motor to the switch. We have to do some fitting, the fan and the wheels. The battery have to go in. We call that pressing. And then you're ready to transport your car to the race. So given this assembly process description, now we have to do an FMEA. So we're given this template. We've got a process or function. Then we have a potential failure mode, potential effect of the failure, which is given a severity number S. Potential cause is then given an occurrence O, and the ability to detect the cause is given a detectability rating of D, and the RPN, as we said, is S times O times D. Now, how do we come up with these numbers? Now, this is an example. This is always a big question in my class because we're not doing anything that's, we're not working in industry, we're just building these little cars. So basically, severity of effect. Here, the example, the worse is better. So 10 is bad. May result in safety issue or regulatory violation without warning. It could be something that could kill somebody. If you're looking at it, depending on how you're rating it, you could say, well, you know, it's not giving us the effect that we want. So we're going to also rate that as high. But generally here we're looking at sort of safety issues or regulatory violations down to 1 where you have little or no impact. So again, I think This is part of the FMEA process, and it would be something that would be relevant to your industry and for that product or part that you're working on. Probability of occurrence, again, depends what you're talking about. For example, in the automobile industry, you need to be very, very careful. If you're looking at wheels falling off, you definitely don't want that to happen very often. Here, for example, a 10 would be, for example, 1 and 2. This is example only. While 1, so a low probability of occurrence is 1 in 1 million, for example. This is them. So this is also bad. And here for detection, if you're very, very uncertain that the failure will be detected, then you have to give it a rating of 10, which is again bad. If you're sure you could detect it, then you give it a 1. So this is the idea that 10 is bad and 1 is good. And that's as far as we need to learn in this course. So the next step, though, you have to think. You sit there and you look at your car, your little paper car, and you look at the process that you've got, and you're not actually building anything. You're just discussing. And a quality manager then would bring all the experts. This is a cross-functional team. You don't know all the details. You bring the team together, and you say, well, for one particular then effect with a certain severity, what could be the different causes that we could have? What could be the different causes? And this is then your failure mode. The causes produce this failure mode, which then produces some effect. And so you draw things out, you talk together, you brainstorm, you use the information they had before, and you start to fill out your table. And so I've already started filling that. We've got a process function: cutting, bonding, taping, wiring, fitting, and pressing. Potential failure mode. So this is a very big table here, but for example, for cutting, the structure could be unstable because you've cut wrong. The car would wobble. Now, in this case, it's not going to kill anybody, but for the purpose of winning the race, it's not very good. This person has given a severity rating of 8, and the cutting is not precise enough. Well, that can happen a lot. So O becomes a high number, bad, 9, but you can detect it pretty easily. So you go to a 4. RPN is then 288, and so forth and so forth. Let's look at here the worst one, bonding. So I should say pylon to chassis. The pylon doesn't stick; it falls over. So that's potential effect then is that the car doesn't move because the pylon collapses and you can't, the propeller doesn't work. So severity there, 9. You won't win the race. Possibly you could have used the wrong glue. That's one of the possible causes. Here we only have one cause for each one, but the occurrence there is pretty high. The glue's pretty bad that we're using, and you can't really see that. So you get the highest RPN number. So the next step of this then would be to look at everything you've got here. Here's another high one. Here's another high one. Tape dissolves. I don't think that happens. I would say occurrence there is very low. Let's not look at that one. But for example, these two bondings, you end up with your rankings and you look at those with the highest RPNs and you say, what would we do next? And you prioritize them, you give dates that need to be done and people that need to look into it. And so in all of this, here's a little picture again of what's actually happening when we're doing it. You are not the expert, but you're bringing this methodology, and it's a very well-established methodology, into the production in order to learn about your risks and categorize the risks. And that means the moderation of an FMEA is truly crucial for its success. This requires preparation, requires visualization of the topics that you're going to discuss, and very importantly, your experts. And your experts sometimes have to be nudged and encouraged to participate. The design and the process are always interacting. And even although these assessed risk numbers will probably vary between the people, you have something to start with, and then you can do experiments to quantify the risk more accurately if you want to. The FMEA is an accepted basis to justify for investment for preventive actions. And of course, importantly, you have to make sure that your preventive actions are then implemented, which is also one of the roles of the quality manager. So I hope you enjoyed that introduction, and maybe you can build your own little car and see how it works.